Okay, in problem number 6, we're told that traffic flow is defined as the rate at which cars pass through an intersection, measured in cars per minute, and the traffic flow at a particular intersection is modeled by the function f, defined by f of t as 82 plus 4 sine of t over 2 for time between 0 and 30. F of t is measured in cars per minute, and t is measured in minutes. So we want to find out to the nearest whole number how many cars pass through the intersection over the 30-minute period. And so that's just going to be the integral from 0 to 30 of f of t dt. There's no starting value. There's no number of cars that are already in the intersection when the time starts. That doesn't apply in this particular problem. So we're just looking for the number of cars that pass through in the first 30 minutes. So I'm going to go to my calculator, enter that function, and we'll start from there. And so I have the function there. All I'm looking for is the integral from 0 to 30. So if I don't want to set up the window, I can do this quickly using the fn int. Now if I think it might be useful to have the window set up, I can go over for other parts of the problem. I can go from 0 to 30 by 5 is okay, and I can still use -10 to +10 for the y, and then see what happens. Now nothing shows up there. So if I go back to my function, it starts at 82, and then sine at most can be -1 or 1, and we're going to multiply that by 4. So probably I can have this go up to 90 for my y values, and by tens. And if I graph that, now I can see that clearly up there, and I want to find the number. So let me just use the graph, option 7, 0 to 30, and that gives me a total of 2474.08, and I want to round that to the nearest whole number, so it's just 2474. Okay, and if I want to clear that integral off of the screen, remember I can hit second and draw, which is above the program, clear draw, and it sets me up for the next part of the problem. Now for part B, we're asked if the traffic flow is increasing or decreasing at t equals 7. So I want to know if traffic flow is increasing. I don't want to know if it's positive or negative. Obviously it's always positive. You can't have negative traffic flow. You can have 0, or you can have some degree of positive. So we want to know if it's increasing or decreasing. What we're really looking for here is the derivative at time t equals 7. And so to do that, I'm just going to go second calc. I'm going to use option 6 and type in 7, and it gives me a -1.873. And so I record that value. Now what does that tell me? Since f prime of 7 is -1.83, then the traffic flow is decreasing. Alright, that's it for part B. For part C, what is the average value of traffic over the time t equals 10 to 15? And remember that average traffic flow is just going to be the average value of this function, traffic flow, average value of f of t. It's the integral divided by the interval, and the interval goes from 10 to 15, so that's 5. And so we set it up like this: 1/5 of the integral from 10 to 15 f of t dt. And I can go to my calculator now and do second calc. I'm looking for the integral, option 7, from 10 to 15. I find that value, 409, and I'm just going to divide that by 5, and I get 81.9 rounded up. And since that's the average value of that function, it should have the same units as that function, which is cars per minute. Part D asks for the average rate of change of the traffic flow, so that's just the slope of the secant line. And I do that by doing y1 of 15 minus y1 of 10 divided by 10 minus 15 minus 10, which is 5, and I get the value of 1.517, and that's in cars per minute squared.